of chapter 5, which has to do with our inverses and our logarithms. So we kind of played around a little bit in that first section of 5.2. Thank you. When it came to kind of looking at those logarithms and going from logarithms to exponentials, kind of going back and forth between those two. So we have a little bit more of that to work on, and then we get to kind of do the whole part with the inverse. And with the inverse, ultimately, what do we do with the x and y? We switch them, and then we solve it for y. Yep. So we're going to kind of do pretty much those same things when it comes to exponentials and logarithms. Sound like a plan? So what is a logarithm, right? So we kind of talked about this. Ooh, that blue's a little hard to see, isn't it? Last week in the previous little section when it came to going from like the logarithms to the exponentials and from exponentials to logarithms, right? So, and we kind of called like B like is our base. So when it came to our exponential, B was our base, right? Whatever our logarithm equaled, that became our exponent. And then that was our number, and that equaled our number. Remember that good little guy that we were working on? Yes, Mrs. Fitch, we do. Oh, good job. I'm glad you remembered that. That's good information. Right. So we're going to do some more of those a little bit on here. I'm going to make this guy a little bigger for us, right? So if anything, kind of come up with a little, if we had our log base B of, I don't know, let's say x equals y, because we like y equals, right? And then if we wanted to take that logarithm and we wanted to turn it into an exponential, our base would be B. Get how that works? Base B, right? Mm-hmm. Our exponent, which would be what letter? The y, right? I know. And that equals our x, right?
So I just need to label those again.
Yep, and you can use like whatever. I mean, I leave the B as the B just because it's the base in either one of them. But different people do different letters. You could
what's
even.
The exponent?
Yeah, so you could do. Whoops, let's stick with blue. We could do log base B of the number equals the exponent. Bini equals the base raised to the exponent equals the number. So Bini equals Ben. We could do that, right? Is that Bini?
Now we have too much going on.
Do you know who Bini is? Bini is Ben?
Yeah, I get it.
I don't know. Ben at Bini? Almost. If we did that the opposite way, it almost looks...
So how do you find the values?
Yeah.
Oh,
yeah.
Like
Yep.
something multiplied by the exponent is 32.
Yeah, we're...
Squared by the exponent, so like whatever it is squared is going to be 32.
Sort of, yep.
So it's the square root of 32 is the question mark.
Well, we're going to change it. So anytime they give me, so yeah, we can jump right into the problem since you're sounding so excited, right? Absolutely. So they want us to figure out the value of our logarithm. And when it comes to logarithms, we don't know like the value of logarithms in the top of our head. Like we don't know that log base 2 of 32 equals blah, right? So anytime they give us a logarithm, like change it into an exponential because we're good with working with exponentials, right? So if I had log base 2 of 32 and I want to make it an exponential, my base is going to be 2, and we're going to raise it to the
32nd.
no, to the exponent, right, or whatever, to the question mark, right? What do we want to put in for the question mark? Question mark, or you want to put in y, x, something, right? X. and that's going to equal
32.
32, right? So we have to figure 2 to what power is going to give us 32. So, pardon me, 2 times 2 is
4,
times another 2
8,
times 2
16,
times 2,
36, 32,
32, right? So how many 2's did we need?
5.
5. So what's our x going to equal?
2 to the 5th.
Yeah, and our x is going to be 5, right? Yep.
So 2,
Yeah.
like 2,
2 to the
x
x
equals a half.
equals 1/2, right? So on this one, there's 2 different ways you can think about doing these. I either, let me change this guy to be a fraction, and then I can look at my denominators, right? Or I take this guy and I try to make him where he's like a whole number, where he's not a fraction. So we just have to decide which way we want to go. Do we want this to be a fraction, or for this to not be a fraction? And we can do it both ways, but we got to make a decision for the first.
Well, you can just take it and do 0.5, right? No.
No. So do we want a fraction?
Not a fraction.
Not a fraction. So we want to make this to where it's not a fraction, okay? So it's that 2 that's in the denominator that we have to think about. And like right now, that is like 2 to the first power, right?
By both sides.
So we have to think about our exponents. There's a way that we can take exponents from numerator to denominator. Make it a
Negative.
make it a negative, right? When we put negative on our exponents, it switches it from numerator to denominator or from denominator up to numerator, right? So if I take my 1/2, I can rewrite that, because that's right now like 2 to the first on the bottom. So if I make that a negative, it brings it up to the top. So this is the same thing as 2 to the negative 1. And then we still get our 2 to the x, right? So what do you think our x is going to equal?
Probably -1.
Yeah, that -1, right? Yep. So x equals -1. If you wanted to do it where we went the opposite way, where we made this a fraction, right? So the same thing applies. So like right now on my 2, what's my exponent?
X.
X, right? If I want to make that a fraction and take it down to the denominator, what do I have to do to my exponent? I have to make it negative, right? So this would be 2, whoops, need some room. 1 over 2 to the negative x equals 1 over 2, right? Technically this has got a 1 on it. So if now that my bases are exactly the same, I got 2 and 2. I know like that negative x is going to equal 1, so x has got to be -1. We can do it either way we want to do it. How cool is that?
I'm gonna need to do more.
So
You want to do some more? Okay, let's do some more. Since you said so. Boom! Right? I love these. So fun. All right, so you tell me, what do you think we're going to do for C?
2 to the x equals 4.
2 to the x equals 4, right? So,
So if you were just gonna solve this,
Uh-huh.
then you just do the square root of x on your side, but you're not gonna get an answer, right?
you lucked out on this one by taking that square root of 4 to get it to be 2.
Yeah.
Right, but because that could be an 8, it could be 2 to the x equals 8. What are you going to do? Right. Like if I was 2 to the x equals 8,
When you get a decimal.
no, you're going to get 3. Right. So on these ones, because everything, we try to give you guys a whole bunch of options. You can kind of just go through your head, right? Because you know that's 2 raised to something, so go through all of your 2's. 2 times 2 is Oh, yep, and so my x is 2, right? So sometimes we like to write it out to where you have like 2 to the x, and I know I have to have a 2 for my base, right? Because my base has got to be the same. And then I knew that it was 2. 2 squared is 4. Now that my bases are the same, my x is going to equal 2.
So,
Right.
the next one
Yep.
has to be 0 because anything times 0 is 0.
Oh, let's try it.
Because then you'll get 1, right?
All right, so we have to do 2 to the
X.
x equals
I'm confused.
0.
If you do it 0, then that would
You
have
still
to
have
be,
2,
the
right?
0 would have to be a 1.
Right. So now we're looking 2 to what power is going to give us 0? So 2 to the 1 is going to be 2, right? Anybody know what 2 to the 0 is?
1, right?
1. Yeah. So is there anything that we can do with that 2 to multiply it by something? Like that's got a 2 in it that's going to give us 0?
What is it, like undefined or something?
Yeah, good job. Yep. It's either like undefined or no solution. Yep. Yep.
Wait, okay, let me think that. Why anything, so you multiply 2
Yeah,
to
2.
the 0 power, why is it
Any number raised to 0 power is 1.
Yeah.
1? It's just a
It's just like.
Yep, it is. Yep, yep. And I believe there's an example on here, and then when we get to that example, I'll show you why. It's really cool why. Promise.
Anything used to 0 power equals 1.
All right.
Oh,
So E, we kind of moved where a question mark is, but still the same thing applies like when it comes to writing this as an exponential, right? So what's our base?
2,
Yep. What's our exponent going to be?
3,
Yep. And that's now going to equal our question mark or make it a x if that makes you warm and fuzzy inside. So what's this one going to equal?
8.
Yeah, 8, right? 2 times 2 times 2 is 8. Not too shabby?
sure.
Starting to come together?
Yeah.
All right. Let's try 3 more. Whoa!
not the fraction.
Oh no! Auntie Anne, they gave me fractions. What do we do? Well, Dorothy, we keep going on. We keep working on them because you know why, Dorothy? We're good enough, we're strong enough, and we're doggone it, we're smart enough.
So can you do this one as 0.5?
Well, let's write it out and see what we come up with and talk about it. How's that?
2 to the half equals x.
2 to the 1/2 equals x. Uh-oh, I got some lagging. Come on, there it is. Anybody remember what happens when we have fractional exponents?
No. You have to make a common denominator.
You gotta make a negative or something.
Fractional exponents always give you radicals. So this is where if you have like x raised to the a over b, it's going to give you a radical of x raised to the a, and the root that you're taking is your denominator.
Why?
This is how the rule works.
Well, there's always a reason in math of why sometimes it is.
So on ours, if we were to take our 2 and rewrite it as a radical, all right, the 2 is going to go in the radical. What's our exponent on the 2 going to be?
1,
1. What's the root that we're taking?
2.
To the 2, right?
And that equals x.
Yep. And granted, we never, like when it comes to the square root, we never really put the 2 in the radical, on the outside part, this little piece. Like if it's to the 3rd or to the 4th, we do. But if it's squared, we usually don't. So I'm good with you putting it in there or not putting it in there, right? So like x equals the square root of 2. And we can't simplify it down any further. It's going to turn into a decimal, so we want that exact value, so we're just going to leave it as the square root of 2. Sound good? All right, let's try G. See if we can set it up and go from there. What do we got?
2
Uh-huh.
multiplied with 1 over 16 equals x.
2 to the
X,
x is going to equal
1 over 16.
1 over 16. So this one is pretty much the same thing as, what was it, number B, or letter B that we worked on, right? So we have to make a choice. Do we want to make this guy a fraction, or do we want to make this one a whole number, non-fraction? Which way you guys like going about these? Not a fraction? That's fine. So I'd have 2 to the x. And then how am I going to write 1/16 so that it's not written as a fraction?
16 to the negative 1.
Yep, 16 to the negative 1. Right?
Okay, that makes more sense.
So now I'm looking for 2 to what degree, right? It's going to give me 16. What do you think?
4.
4, right? And then it's going to be a negative 4, right?
Yeah, but why is it, I guess it just confuses me, that 16 and negative 1.
So we went through like a whole bunch of lessons last semester of how to switch variables and letters from numerators to denominators and denominators to numerators, right? And when it comes to top and bottom being exactly the same, you subtract the exponents.
Yeah, so but what do you do with the negative 1? Do you have to do anything with it? Do you just leave it there?
Well, you can either know that that's going to go to negative 4, or from here, this is 2 to the x equals, on that 16, you know that it's 2 to the 4th times that negative 1. So 2 to the x is going to equal 2 to the negative 4. So your x is negative 4.
So you just cut out the steps.
Yeah.
Okay.
Yep. All right. And then on that last one, how are we going to write the last one?
2 to the 0 equals
Yep, 2 to the 0 equals x. Oops, I
so
get
1
X equals 1.
Yep,
equals
x equals 1.
Find the inverse. Oh no.
Right, oh yeah, we're getting there, but we're, yep. Everybody good with anything to the 0 power equals 1? Everybody know why?
Because it's how it is.
Same thing when it came to those numerators and denominators, right? If I had x to the, give me a number, 15 over x to the 15th. So we learned last semester, like when it came to these, like you could subtract, when you divide, you subtract the exponents, right? So if we were just to simplify this without thinking of that method, any fraction or any number over itself is 1, right? So if I were to simplify that, what would I get? What's x to the 15th over x to the 15th? It's going to give you 1, right? If we use the whole property of subtracting our exponents, this would be x to the 15th minus the 15, which is x to the 0, right? And we know that x to the 0 is 1. Yep. All right. So now we get to take all that good little stuff, along with the fact that we know how to find inverses, and then we can put them all together. Right? So find the inverse and write your answer in y form. You guys are good with this. So, yep. So what's the first thing we do when we want to find the inverse? We switch the x's and y's, right? Yep. So what are we going to get?
X equals log 9y.
Yep, log base 9 of y, right? So the problem is, it's like now it's solved for x, and we have that y, which is kind of like there with our log, and those aren't multiplied. I mean, that is a number. So we, like, just leaving it as a log, I'm like, I don't know where to go next. So when I don't know where to go next, I could always make it a, starts with an E,
Exponential function.
exponential function. So if I wanted to convert this into an exponential function, my base would be, yeah, raised to the power of, right? Oh, if you need to, write off your little log base b of a number equals an exponent, right? Which is base raised to the exponent equals the number. So it's going to be 9 raised to the,
I don't know what that exponent is exactly. X, or I don't know why.
I go to the bathroom.
yep. Match up your E's, right? Where am I getting those from? Where's the E coming from?
So it is y.
It's X equals Y. Uh-oh. So did we write the inverse? Yeah. After we wrote the inverse, did we solve it for Y? Yeah. So there we are. So let's try B. So to write the inverse, what's the first thing we do? Switch the x and y. So x equals 10 to the y. Can you algebraically get y out of that exponent right now? No, right? So that's where our little hiccup comes in. So let's try and switch it into a is it exponential or logarithm right now? Right. Yep. So we're going to switch it into a logarithm, right? Log base, yep, little 10
X.
equals
I can tell you that.
y, our exponent. Y. We're just rearranging them.
I thought you were saying what it
Oh, that's what I was hoping for. And then I'm like, are you saying why? Like, I don't know why. Or are you saying why because it's why? I don't know. I think we both read each other backwards. And is it solved for y? Yeah, so we're good to go. All right, let's try the third one. What's the first thing we do?
Switch the x and y.
Yeah, so we have what? X equals log base 6, y plus 1.
So we use 6 to the y plus 1 equals y.
Yeah,
Wait, no.
well, 6. Yep, our base is 6. Which one's our exponent?
See, this is what x. Yeah, x.
Yep, all right, go back to this.
6
Yep,
x equals y plus 1.
yep, equals.
Subtract it.
Oh, look at you. Can't fool you. Yep, 6 to the x minus 1 equals y. See, practice. Look, man, you've been practicing these, and look at you're starting to get them.
That's very good.
Crazy. Told you, Auntie Em. I knew we could do it. All right, so what are we going to do first? Switch the x and y.
See, my biggest fault.
Oh.
Sometimes I forget that the x is there once I put it over there.
All right, I'm going to slide this up a little bit for us to see. Yep. Can we get the y out of the exponent to solve it? No. So that's why we're going to make it a,
No solution.
starts with an L,
Logarithm.
logarithm, right?
Y, what do you
So log base
5
5 of our number
to the
x, right,
Yeah.
equals our exponent. And what's our exponent? 2y. Yep.
Okay. Divided by 2.
And then divide both sides by 2.
We hate to see it.
Right. So we get y equals log base 5 x all divided by 2. Not too shabs? Alright. So in your guys' math notes in the book, I'll leave it up here for you guys as well. It has to do with the logarithm and that notation, right? Just making sure you guys know how to write it. And then it also has the little, like they use those x's and y's of going from logs to exponents and exponents to logs. So like I said, it doesn't matter like what letters you put into that. Like I just always use that B for the base just because I think that's pretty standard, you know what I mean? Because we call both of those parts of both of those problems bases. So I try to keep that as a B. But whatever you want to put in for that number and that exponent, as long as they like match up from one to the next to help you figure out going back and forth between the two, it helps out, right? I sometimes have the cheesy, this is really cheesy. Let me find where I put that at the beginning. Yeah, we can do this one. Like when it comes to going from logarithm to an exponent, hopefully we know we have to start with the base. But if you go from the base, this is your exponent. This is what it equals. It kind of makes an E.
An E.
Get it? Right? If I make the E, that's how I can convert it into an exponential. We know we got to start with the base, right? And if I go, my base of my number equals my exponent, I made a
L.
L. So if I want to write it as a logarithm, I'm like making that L. Oops, thing's timing out on me. I make that L. Then you can kind of come up, then it makes a bubble letter and then it's really cute, right? And if I have a logarithm and I want to make it an exponential, I'm trying to make that E, right? Base exponent equals, right? Base exponent equals. Right?